Metals are some of the strongest materials on Earth. The strongest material ever recorded was an alloy of chromium, cobalt, and nickel. Alloys achieve their high strength by evenly combining the attributes of each component metal through even grain distribution. However, if not cooled properly, alloys can become brittle and weak due to a phenomenon called coring. Coring occurs during the metal solidification process when each component metal is still liquid but cooling down. For a metal to solidify, it must reach a cool enough temperature for grains to start forming. Grains are small regions where the properties of the metal are uniform. In an alloy, each grain contains only one metal, but the different grains are distributed evenly throughout the alloy. Grains form at high energy nucleation sites, such as dust particles or other grain boundaries. As grain boundaries are high energy compared to the liquid metal, the formation of one grain catalyzes the solidification of the rest of the liquid. In a liquid alloy, there exists a range of temperatures where only one of the component metals can solidify. Under normal conditions, grains of both metals form and connect to each other, slowly and evenly distributing over time. When cooled very rapidly, grains of the higher melting point metal form individually without building upon other grains. When the lower melting point metal begins to solidify, it forms at the grain boundaries of the higher melting point metal. This creates a cored grain structure where the higher melting point metal exists within a region of lower melting point metal. This rapid cooling that causes coring also causes the grain sizes to become uneven. Uneven grain sizes causes stress to concentrate on the larger grains while the smaller grains restrict the ductility of the metal. The uneven grain distribution and uneven grain sizes causes a weak and brittle metal to form. As a result, industrial alloy casting must allow cooling to happen slowly in order to avoid coring, which would ruin the metal for any practical use.